Hey, my name is Ryle and I'm in my final trimester at JMC Academy studying a Bachelor of Creative Technology, Audio Engineering and Sound Production. What you just saw was my major project, which is an 1176 Revision D kit made by Hairball Audio. Another part of this project includes an attempt at creating a wet-dry modification to the kit, which I'll explain later in the video, as well as an artwork on top of the compressor. Anyways, you may or may not be wondering why I chose to build a kit instead of doing the typical project of recording, mixing, and mastering a band myself. And well, it's because this is something I want to do as a career. Building, designing, repairing, and/or maintaining audio gear, and potentially even starting my own business in the future, recycling and reusing electronic components to rebuild and repair more gear. So what can you expect from this video? This will include the total build process of the 1176 kit, soldering, calibrating, and modding, a week in my life, how I balance my study, work, and social life, the modification and artwork, functionality testing, a plugin comparison, and a final reflection. So let's get to it. This was super frustrating for me because I didn't have a cable stripper, meaning I had to do it manually. So I took a break, went to work, and did it again when I got back home.
Let's go.
Okay. Anything that is 0.2 is good. 0.2 of 3. Yep, okay.
It's okay?
That's fine. Yeah, I haven't turned it on though.
Yeah?
I haven't turned it on though.
Oh, okay.
Now it's the real deal.
Nothing exploded.
Not the capacitors haven't exploded. This should read 30 V. Let's check. 30 VDC. Okay. Okay. 30.96.
Yeah?
That's good.
Okay.
That's good. Yeah. And then
It's not like 50.
yeah. And then the diode is has to be minus 10. Minus 9.
Yeah, close enough.
Point, yeah, it's like plus or minus 5. Okay. How terrifying.
Yes. Let's go.
With the Q bias adjustment, we need to input XLR test points to reach 0.775 AC volts. And then turn the Q bias trim pot fully clockwise. By slowly turning the Q-bias trim pot counterclockwise, we should reach a drop of 1 dB and the VU meter to read 0 VU. To set the null adjustment, we need both of these conditions to be met. 1. Zeroing the GR meter using the 2K trim pot on the front panel, and 2. Our digital multimeter to read 0.0 DC volts across the test points. Now that the attack is fully on and it is currently at 0, I want it to set it to -10 using the tracking adjust trimmer to set it to -10 while the volts are at 0 dBu or 0.775 volts. After a lot of finicking with the 2K trim pot and the tracking adjustment trim pot, finally done it. When attack is on, it goes straight to -10. For these comparisons, you'll hear the 1176 hardware compressor, the plugin version of itself, and Purple Audio's MC77 plugin. These will showcase how each one shapes the tone and dynamics of the source. For each source, I'm running the exact same audio with the same settings of ratio, attack, release, and gain reduction, but with different threshold and makeup gain settings. This is because the settings for analog gear and plugins do not translate the same way. As you listen, pay attention to the transient response, dynamic range, tone, and sustain. Out of the three, the hardware compressor gives the kick a richer thump, while still retaining the click. The plugins sound very similar and are slightly overcompressed as the kick sounds too clicky. Now for the vocals.
Don't you look my way! Be in a war of pain! Don't you look my way! Be in a war of pain! Don't you look my way! Be in a war of pain!
For this source, the 1176 plugin sounds the best as it provides the right amount of aggression and dynamic range, whereas the MC77 doesn't have the clarity and the hardware compressor makes the vocals sound too aggressive. Now onto guitars. With guitars, since they're already very harmonically dense, hardware and plugins behave almost identically, so if you want a compressor, consider your source material first. So what is this wet-dry modification I said in the beginning? Well, if you don't know, it's essentially taking the input signal and splitting it into two paths. The first path is natural/unprocessed, aka a dry signal, and the second path has been compressed, creating a wet signal. Now blending the two audio signals, we can control how wet or dry the signal is. This is also known as parallel compression. The circuit for this modification is an active summing circuit, which takes multiple voltage input points and combines them into one single output, which is proportional to the weighted sum of those inputs. The electronic components needed for this are as follows: an op-amp and an IC socket, equal value input resistors for each signal, a feedback resistor to set the gain of the op-amp, coupling capacitors to block DC for clean audio, jumper wires, and a potentiometer to control the blend of the signals. but for the modification to work, we need to tap points for the dry and wet signal, which can be seen in the schematic for the 1176. The dry tap is at the collector node of the Q2 transistor marked by 1.78, while the wet tap is at the collector node of the Q5 transistor marked by 25.1. Unfortunately, I was unable to get any further, but for future research and development, testing can be done by digitally assembling the modification circuit on KiCad and testing it with KiCad circuit simulation. Further development can be made by creating a PCB design in KiCad and ordering the custom PCB from manufacturers. Time for the real deal. From the start of this project till now, it's been an incredible journey. Building the kit was quite fun despite the minor errors I made along the way. Calibrating, functionality, and comparison testing took a little bit to figure out. Frustrating at times, but I learned a lot doing them. The artwork is, although quite simple, took much longer than I thought, but looking back, it makes sense because I used a box cutter and the scissors to cut out the stencil. My initial plan for this project was also a whole lot different aesthetic-wise, but I do like this end product more. And after a lot of sleepless nights trying to finish this project whilst balancing my other assignments, work, and a decent social life, I can say it was worth it, especially since I essentially did this entire project myself. Big thanks to everyone that assisted me along the way. I hope you enjoyed it.